Next, always a NSGIC favorite. Getting a good dose of Next Gen 9-1-1 from Richard Kelly, 911 Data Master. Take it away, Richard. We all set?
Great. Can you hear me okay?
Yes.
We're going to go through this rapid fire, everyone. I'm glad to be here again.
Could you turn your, do you have a video to turn on of your camera feed?
Should be able to see, hopefully, now let me get this going here. Yeah, that'll help, won't it? Let's see if we get the presentation going.
Yeah, your presentation's running.
Okay, good.
Get your camera. There it is.
Okay.
Hey, nice to see
everybody.
You.
Sorry, I'm so used to isolation here. Y'all don't know what that is, right? We've all had that for the last 2 years. Again, thanks for letting me give you an update on the NENA side. There will be a lot of slides here. You don't have to read them all or copy anything down. You're all welcome to the content afterwards. And I'll go through, not word for word, but most of the content on these slides. So as a reminder, for those of you who are not aware, the National Emergency Number Association is designed to create the standardized guidelines by which 911 systems, technology, and operations operate, and their interoperability. They take that very seriously, and because of that, all the standards and documents we're going to give you an update on conform to the American National Standards Institute guidelines for how these should be built and designed, and that's an accepted standard that we follow. So we're an ANSI accredited organization. Now, here's the boring stuff. I wanted you folks to be aware of NENA works, I think, at any given time on 40 to 50 different documents for standards and guidelines. They fall in several categories. Of these categories, we're most interested in the STA, the standard, which basically describes what you're supposed to do and how to do it. Manufacturers, people who manage organizations follow those standards. Then we have requirements document. We'll talk about both standards and requirements today. Requirements documents are almost an encyclopedic combination of knowledge, particularly when we talk about 3D and how that's going to affect GIS. That'll be a requirements area we've been building information on. And then there's informational documents. You can't make people do things in informational documents because there may be a lot of different ways to handle the same kinds of tasks. But the requirements and informational documents together provide the guidance by which things should go down, and they're great references. And of course, we've got reference documents. So we'll talk about standards, requirements, and information documents today. This is just a listing of currently the documents, and as you notice, though, some will be informational documents indicated by the INF or standards indicated by STA. There's a variety of things related to GIS. Look at all these. These are the ones that are currently available now, or if you see highlighting, like the Civic Location Data Exchange format, are under review and development for a new version. So there's a number of things going on right now. CLDX FB2 is preparing for a public review. That will stipulate how location information is provided to systems within 911, and that's derivative of the FGGC information. And then you go on to the data model we'll talk about here in a minute, along with the rest of them. Gives you an idea, a quick snapshot of where everything is, along with what the document reference IDs are. So you can use this slide later to look things up. Now, today we're going to have two different things we're looking at. Two-dimensional data is something we've been used to for, well, as long as I've been in this business. Maps, right? Flat, edge of the world kind of stuff. It's important to understand that next generation 911, 911 calls don't necessarily go to the 911 center simply by accessing a tabular database. What we're going to have now is have a location that's captured by the devices and network of the caller, and it has to be compared to the 911 centers that can respond to it. And that's fine, but sometimes the information is not what we want it to be. You can get an X and Y from a device, which is easy enough, but if you get a 105 Main Street, you can't really equate that to where it falls within a jurisdiction. So we require certain GIS layers to accomplish this true GIS point polygon analysis. We need something called a PSAP boundary, and PSAPs are public safety answering points, 911 centers. Service boundaries, which would be your responders, fire, alarm, medical. Road center lines to help us geocode where location is so we can figure out which polygon it falls in. And site structure points, which are better than road center lines because they're more discrete information, but they're a little more challenging to build over time. So moving on to the next slide here, what we want to show you is probably the key standard. It's a lot, and there's a big paragraph of text there. all I want you to take away from this is that there's one big document, the I3 standard, STA010. We wrapped up the third version not too long ago, about 670 pages. Not an easy read, but there's a lot of things in it dealing with GIS. What I've done is pulled out some of those sections which directly affect folks who have to build GIS data and provide it from the public safety side. So we have to build GIS data for distribution, for use in map displays, CAD systems, now to drive the slide we just showed you where we're determining where the caller, based on their location and the GIS data on board the system doing the analysis, where it needs to go. But there's a whole litany of different things we have to get into. Each one could take their own presentation up. What you'll be most interested in, I believe, will be the GIS data model. What's great about this, we're in version 2 right now. We've got that work well underway. That has been released for public review, and that wrapped up yesterday, public review and comments. So if any of you were able to participate and provide feedback, that's great. It describes the schema, the structure for road center lines, site structure, service boundaries, and what have you. There were some additions put into it because we not only support the United States, but Canada. So for North America, we added additional information. There is a specific taxonomy now for unique IDs. It's a 4-part construct described within this document. I've talked to some of you in some of our speed networking. Do check that out, because if you're working from a state level or even a regional, local, even national, you want to understand how we're going to have to be able to take in, utilize, or even track a feature by a unique ID. You'll want to see what that guidance is. Remember, this is a standard, so people who are participating in the next generation of 911 data development and provisioning will have to follow that structure. There's also a registry of the types of data. It's really matured since the last time we spoke about the data model a while back. So there's some good stuff in here you're going to want to keep track of. Just a sample. This is going to be a selection of data attributes that's reflective of the site structure address points. You'll notice there's a variety of fields, or scripted name, field name. There's a qualification, whether it's mandatory for M, conditional, or if it's optional, along with the type and the width. Within this, these attributions are so critical for next generation 911. We have to have a routing information contained with all of the site structure address points and the road center lines. We also have data that's based on what we use today, the ALI, the automatic location information, and the master address guide, the MSAG information. That's contained in legacy fields. Think about it this way. Address points and road center lines can be the Rosetta Stone, the translate, if you will, between what we know from what's in purple, the legacy or historical information we've been compiling and using in 911 since the 70s, with what we need to know what's on the ground, what's actual from a pure GIS and next generation perspective or the naming convention. So we have to have county, state, country, all of that in addition to the street name components, while the conversion needs to have the legacy. Then we talk about subaddressing. The big thing here, FCC mandated we need to improve upon our ability to identify a caller from something other than a street and a particular address, because you can have multiple units and apartments and buildings at a particular address. So subaddressing came into the equation, where we have building, floor, unit, room, and seat. But because that's not readily creatable and introducible into the existing database structures, we have to go a little different. We have to start talking about elevation and height, and that brings into the equation again z-value. So even on the site structure address point layer, we have a recommendation to put a z-value indicator. Now, as I said, this data model, which incorporates all these schemas for the key layers necessary, that closed yesterday. We're hopeful to get that turned around in not too long a time. So keep your eyes open and your ears ready to go for an update we can get. And I know our next generation work group here within NSGIC does a good job of keeping everybody up to date. I do want to let you know that the data model does not stop at version 2. We started that project in 2010. I know because I was part of it for the first 10 years, and now we're going into the next iteration. After we release this on version 3, we'll be looking at what is the necessity to differentiate between conditional and mandatory, a variety of things. You'll see these things in here. for version 3, version 4, version 5, version 6, version 7. While these are not firm versions to be lined up, because we would be doing this almost for perpetuity, we do look at some of these might be done as parallel work group efforts. So there's a lot of work being taken under advisement. Notice in version 7, we start talking about national data sets. So the feds, if you're looking at hydrology and railroads, there'll be a need for having that data that's consistent between states to be represented on map displays, CAD systems, and everything else, and maybe as a streaming data service. We're getting to the whole world of cloud computing and streaming data, and NENA's trying to prepare for that. Along with that, we've talked about the NAD, we talked about site structure, address polygons, and building footprints. We heard in the last discussion, parcels. There's so many things we could do. How do we manage it without becoming overwhelmed? Local governments really have a challenge doing that. But we have the NG9-1-1 GIS data stewardship guidance, which is wrapping up its first iteration for road center lines and polygons. I'm showing you an example here that we're looking at road center lines where they have requirements, recommendations, and for the first time, a phased approach. How should you build this data? And NENA's taking great pains over the last few years to build this guidance out. Now local governments can understand what NENA recommends to do in building out this data. We're going to hopefully have it out for public review very shortly, then maybe get that commentary adjudicated, maybe get that document ready before the end of the year. Site structure address points will come in after we get that done. Now that's all great, but what's all this noise about 3D? NENA realizes that understanding the location of a caller and the responders to that caller's location with a vertical perspective is important. Yes, we can show on a flat display with a map or a CAD system where a caller is and the responders, but we start dealing with challenges within a three-dimensional structure, buildings, of course, towers, things of that nature. And we're just talking about dealing with the response, not necessarily a live situation. We're trying to analyze movements within a structure. So NENA's embarked on a new document a couple of years ago dealing with 3D location in 911 today. The document's supposed to educate the reader on location technologies. It's very thorough. We just wrapped up a few hours ago getting the vote that it's going to be rolling out for public review. So all of you who are hearing this can get a crack at looking at this document. It's going to provide guidelines. It's a requirements document. As I mentioned at the beginning, the requirements will be a compilation of knowledge to be used for standards and the stewardship and anything else that can feed off of it on what it says are the parameters by which 3D data should be utilized, viewed. It's a great document. As you would imagine, there's a lot of content in here. It's designed, again, to support the regulatory environment, not just here, but also in Canada and maybe even beyond as we look at what's being done around the world. So keep in mind, at this time, there's no specific 3D requirements. We're trying to get ahead of the curve. Yay. Location 3D mapping of it, keep in mind that when we talk about location in 911, we're going to talk about civic location, which is that building floor unit that we'd like to have. We can't really contain that yet in a database structure through the providers. So Z comes into play. The reference terms are going to be civic location, a dispatchable location, which is really a human readable estimated address, a geodetic location, which is the X, Y, and now Z with uncertainty. How far off are we? FCC would like to see 3 meters or less accuracy. Stated location, that's still always valid. The caller telling you they're in a broom closet or stairwell or what have you, and within a certain building or apartment. And then we get into 3D mapping technology. We have to understand what 3D mapping is. It's mapping systems used for GIS that now have vertical measurement. And yeah, this will have to take into account, how do we build data with a Z context? Do I need to have wireframe diagrams? All of this is contained within the document, but we start with the basics. When we look at a two-dimensional call location, and we're going to get some coordinates for it, we have to have that context for spatial distribution of roads and water and everything else, all the human developed structures as well as the landforms. That introduces some variability when we get a wireless location, for example, of an X and Y, that we have to qualify as uncertainty and confidence. And this is important because if we're trying to hit a certain level, and NENA has established in concert with the FCC that when you call on your cell phone, for those of you who may not be aware of it, we have to make sure that you're able to be located within 50 meters 90% of the time. And that's a big target. And most of the providers do a much better job than that. So not to worry. Z-value introduces a little bit different consideration. Give you this example here. I was asked just yesterday, what's the big deal with Z-value? What difference does it make? Well, if we're looking at a bridge here over San Francisco and we've got an incident on the road, and you've got a bunch of callers, it's important to understand that the Z-value could indicate whether or not the incident's on the bridge or on the water, because that can make a difference. And the term we use is altitude for that location, how the Z reflects that. It's important to understand that because we need to know if the response should be from the city or if it should be from Coast Guard or patrol in the harbor or what have you. So it's important to understand that Z context, not only for routing the call, if there's a specific PSAP that responds to on the bridge or not, but also the responders. That brings into the case for consideration that if I get you a good call location with pretty decent confidence and certainty, can I narrow it down to a room? And that's the goal. We want to get it down to a human understandable location. The document goes into some of your favorite topics, digital elevation models, DEMs, DTMs. We're going to talk about the resolution of these models. We'll talk about everything in it and stuff I haven't looked at in a long time, particularly with regards to LiDAR, how this data is collected and utilized. There's hard math in this where we talk about the algorithms for measurements, the delivery of a Z-value, what are the variables in it. As I said, as a requirements document, it has to provide a lot of background. And while it's very technical and it's nicely organized, it still should be fairly consumable by the lay reader. That's what we've tried to balance out. And it's an exciting document. You see some screenshots of some of the graphics we actually have from the document. Each of them will have caption descriptions of what they're relaying. If you're talking about a triangular regular network of 10, or if you're talking about smoothing of imagery, this is obviously going to go to some of the resources NSGIC's been working on, everything from coastal erosion to impervious surface data. So it's exciting that we can get into this. And there's even recommendations to use data that's freely available, whether it's USGS or what have you. Again, I'm just giving you some candy shots here to get your appetite whetted to go in and look at the kind of information it's going to reference. We talk about extruded buildings. There are footprints available in many states across the United States. So with that, I guess great power, great data comes great responsibility, to use that phrase another way. We try to warn people about some of the challenges using this, but also steer them to where there's good data to start from. The goal, of course, would be to get to where we can locate a caller who's unable to respond within a building or within a building footprint. If you can look at a floor plan and have it a reference to an elevation or a height, that's good. But then that brings into, what we know from the GIS side brings into the question, well, how do I build that data? How am I going to manage that? We already are way overhead heavy on how much we can do with the limited resources we have. So as a requirements document, we look at this as something that we want to put out there, get people to know and understand up front, and maybe pursue legislation that would help secure additional funding. We could spend a whole bunch of time on how federal funding is now being provided to next generation 9-1 data development around the country. I know in Texas, we had $150 million that was able to be distributed through the State 9-1 Commission. And there are other states doing similar legislative approaches to getting funding. We have to be cognizant. We want to make sure we get the biggest bang for the buck. So building roads and center lines, to me, not sexy for a lot of people. That's the primary data set, that and polygon patterns. So we adjudicated the comments, 60 in all. As of today, that's getting approval right now. Now, it doesn't stop there. What we're looking at in the future, NENA's well aware that besides 3D and Z-value, and I hope this whets your appetite because I want you to grab that document, we have to deal with not only dispatchable location, but CAD database interoperability. I know I'm working on the APCO side as well, and they're looking at how to deal with CAD GIS data interoperability to take advantage of the distribution networks that are going to be an imperative for next gen 9-1-1. How do we deal with 3D information implementation? We're talking about from a data building and administration perspective. Do I now need to have a map display that leverages a 3D oblique perspective? How do I visualize that in the call handling center or an ambulance? I mean, we're not talking about Star Wars or CSI where I have a 3D building I can rotate freely, or are we? Are we going to get in wireframe diagrams? There's the Internet of Things NENA needs to tackle. Artificial intelligence is making its way into discussions about how much we can use AI in call handling. As you could imagine, that's can be a little controversial. Drones in real time, that comes from situations of doing real-time video capture, feeding into the PSAP. Cloud-based solutions, I can tell you right now from my work around the country, cloud-based technology with lots of redundancy is the way many 911 structures are going. With that is going to go security interests and concerns. So much tech, you could just, your eyes will just go blind trying to read all the different document standards proposals. I'm bringing this back around to what we said at the beginning. Right now, the 5 primary documents dealing with GIS we're working on, again, CLDXF, Specific Location Data Exchange Format, the GIS data model, the GIS data stewardship, how to build the data and manage it over time, the transition, how do you get your old GIS data into the new format? That work group is underway. Nothing really to report on it yet. And then, of course, the 3D location data requirements document I'd like you guys to look at. When you get a hold of this deck, and I certainly hope you get it, there is a way to go in and check out how to get involved with these work groups. We send out notifications for people to download and look at standards and requirements and informational documents so they can put in comments. Again, the Next Gen group here has been good about notifying the district leadership. But bear in mind, you go directly to the NENA webpage, go in, find a group you want to get involved with, and join. And I'm more than willing to help you guys, welcome you to the fold and get you involved with these work groups. Now, if you got, we got a few more minutes. If you've got some questions, let's go through them. But again, take the deck when you get it and look at some of the bulleted items I've tried to collect for you to give you a sense for what's happening in these documents so that you'll know whether it's relevant or not to your area of work or to your state. With that, I'll pass it on if we've got some questions in the chat box, and I need to catch up on that. Any questions? That good. All right. Well, if we don't have any more questions, unless there's a hand up I can't see. The question.
Hey, Richard, this is Kevin. I threw a question into the chat, so but I'm not sure if you saw it. So, you know, and I think Neil also mentioned something too in there too in the chat too. But generating these 3D data sets is quite the endeavor. I mean, you can only imagine. Yeah. You know, building it for 2D and trying to do it in 3D.
Oh, yeah.
And then not only that is that, you know, there are ways to do it, and you build it. Now you have this massive data set that is,
yes.
I mean, absolutely massive. How are the CAD and dispatch systems actually going to even be able to support it? And like, what time frame will these other systems be built to handle that kind of?
So that's a great question. One of the things that's driving us on the 3D side is that commercial side, the software manufacturers already coming up with ways to deal with 3D GIS as far as applications throughout life. There's different things you can use it for. And what that's driving is more public requests for getting an understanding. Why can't you see where I am? Why can't you look into my living room? I mean, most of us don't want that. But a lot of drive is when technology is available, why aren't you implementing it? And 911's always had a challenge finding out just because you can do something, should you do something? And the challenge for us is, yeah, the administration of that would be a nightmare. I would look at this as more, not experimental, but gathering the data and the knowledge we have now so we can provide guidance for future discussions, if that makes sense. What's our benchmark, our level set on this subject? And that's what NENA's been trying to do, if that makes sense. With CADs can be basic, or they can be fairly advanced on how they're rendering and doing representations. As we see more systems bringing in oblique imagery, wireframe diagrams, and leveraging these real three-dimensional modeling capabilities that have really been the purview of architects and people designing mock-ups for what could look like a new building or a community. We see some of that, the questions about being to import that capability into public safety. Right now, CAD interoperability and using data sets that are, let's say, NENA compliant in CAD systems is a big challenge. NENA's looking at that, APCO's looking at that. How do we deal with interoperability so we can distribute the same data to multiple CAD systems and between CAD systems? I would say that's going to come first before we get into any real 3D world for this. I would say that the people who are looking at 3D most closely would be the major metropolitan cities. If you're looking at Los Angeles, you're looking at Chicago or other places, they may be working in some areas. I know Chicago was looking at some internal location technology that was pretty advanced. So it really depends where you are. And so Neil, being consistently maintained is going to be a challenge, as I just said, for all of you. And Mark, when they're working with PSAP owners, I know that Houston is receiving Z value, and they had already built Z values into their site structure address point layer. But how it's used in software in actual implementations is different. I know some companies up north have tried some experimentation with 3D room renderings. You may know who some of them are, working with ESRI and doing visualization inside buildings. One of the challenges that I find always head scratch worthy is the discussion that we should get away from road center lines and address points for any kind of location technology and go to three-dimensionally rendered room spaces, so that every single building and room has a three-dimensional space that can be ported in somehow into the 911 system. I don't see that happening in my lifetime, but that's just my opinion. It makes it a challenge. How are we going to do some of this? Again, we could talk about a lot of this. 3D goes all over the place. But what I would ask all of you, if you're interested in the subject, please look at the document. It was out for public review. If you want to get the public review copy and you didn't get it yet, let me know, or we can give it to the Next Gen group. I think you guys should have access to that already, and then watch to see what comes out. It should have some good content for you. And I think that just about wraps up the time. I think I covered all the questions in the box.
We do have time. We do have time to go to the virtual audience, in that there is some comment there that Jamie maybe would like to facilitate for us.
Yeah, I'm happy to. There was a great question from Mark Holmes. Mark, do you feel comfortable coming off mute?
Yeah, Richard answered a bit of it there in the last little portion, but I'm actually curious. I know, Richard, with the multi-line telephone systems, I don't know how much was legislated or at what level, but there was some discussion, some building owners had to provide databases in with all the extensions in there. I don't know how that all, worked from an operational standpoint, how effective it was, but do you see the building thing being kind of the same thing where certain size buildings may have to provide their floor plans or information to PSAPs? There's been any discussion around
I stopped short of putting that in, Mark. You're referring to Kerry's law, which was enacted and took effect, that stipulated you had to have some more granular location than just a 105 Main Street, and that you didn't have to dial 9 getting out of a building. You needed to be able to dial 911 directly and have location information through Ray Baum's Act, which was a follow-up that said, give me what room I'm in at the hotel in the apartment, or what have you. That makes it a challenge. It's easy enough to pass legislation that requires something to be done, but we all know on this call, building that data that supports the infrastructure to match up what comes in with location, if you have that in the first place, with some kind of system that could adjudicate where to send the call and what kind of responders, that's a challenge. So what we look at is how we have to build the data, but systems right now are able to deliver Z value. And if they're provided the data, if your service providers have an input of, I'm calling from this telephone in this motel, I'm in room 106, if they can, through a private branch exchange, a PBX, have some way to attributing, and they should have that now, that was part of the legislation, attributing what room you're in, what part of the building that is provided along with the general address location, that can be received at the 911 call center. That was the whole goal. What I'm getting at is, how does that come into play with regards to mapping, map display, or call routing? And that's a slightly different animal. But yes, the legislation required that we have that granularity of location, and that is supposed to be implemented already around the United States to differing degrees of success at this point.
It's fantastic, Richard. We really appreciate your continued heartbeat on keeping us up to speed on all this. We would be sort of lost without you. So thanks. Let's hear it for Richard.
Yeah.